This is Jeremy Clark of JeremyBytes.com, and today we're going to be looking at the basics of using Git. And I'm approaching this from the standpoint of Visual Studio developers. The reason I'm doing this is because a lot of us are familiar with centralized source control systems like TFS, but we're not quite familiar with the distributed systems like Git. Now today we'll be looking at some of the basic commands in Git, including creating a new repository and using some of the built-in features that we have in Visual Studio 2013. Now the tools in Visual Studio 2015 are a little bit different, but I like to show 2013 since it's a little bit easier to work with. So let's head over to our code and get started using Git. So we're going to start out with a project that I've already created called Lambda Expressions. And this is a pretty simple application, as we'll see in just a minute. But before I open it up in Visual Studio, let's go ahead and open up a command line so that we can get started using Git. Now, when I did the installation of Git, I used the defaults. And part of the default installation is to add Git to the path of our system. That means we can open up any command prompt and start using it right from here. So here I am in the folder for my solution, and to create a new Git repository, I'm just going to type git init. Now, if we flip over to our file system, what we'll see is that we have a new hidden folder, .git. Now, the interesting thing about this folder is it includes the entire repository. That means it will include all of the history for this particular repository, all on my local machine. Now, this is a hidden folder, so if you don't have hidden folders showing, you will not see this. So now that we have our repository, let's go ahead and start using it. I'm going to start out with git status. The files in red are untracked files, so before we can put these into our repository, we'll need to add them so that they are tracked. But before we do that, I want to point out that there's some files that we probably don't want to include in our repository. One of those is the .suo folder. This actually contains the user settings for our solution, and it's something we don't normally want in source control. And there's some other files that we want to exclude as well. Well, Git gives us an easy way to do this with configuration. There's a file called gitignore that we can use. Now I have one here on my desktop, so I'm just going to drag it into my folder. And now watch what happens when I say git status. Now we can see that the suo file is no longer showing. That's because it is being excluded by Git. So let's just pop open the gitignore to see what's inside. What we can see here is there are a lot of exclusions in this file. Now this is specifically for Visual Studio, and it's set up for the things that we normally want to exclude from our Visual Studio repositories. So this does include the things like the suo file, as well as some other user files. And it also includes our output folders, so our debug, release, as well as some temporary folders including obj and bin. Now you probably don't want to build this file yourself. Now fortunately for us, there is a GitHub project for gitignore files, and it includes a variety of environments, including Visual Studio. Now me personally, I generally need just the basics, so I'll go ahead and keep a copy of gitignore on my local machine, and then just copy it into my folders where I need it. Now I mentioned that we will need to add files before we can commit them to our repository. And fortunately, Git gives us a lot of help here. We can see that we have a note here to use git add to track the files. So let's do just that. So I'm going to say git add dot, and what that will do is it will start tracking all of the folders. Now Git does have its roots in the Linux environment, so there are a lot of command line options that follow those conventions. So when we use dot, that's the equivalent of star that we normally have on the command line. So let's do another git status to see what we have. Now we can see that all of these files are listed in green. That means that these are now being tracked. And if you'll notice, this is showing us all of the files in the full folder structure that we have here. So all of these files in the project are now being tracked, and they're ready for us to commit to our repository. But before we do that, let's open up Visual Studio to see what we have here. Now I don't have any special plugins for Git installed on my machine, so the functionality that we see here is what we get out of the box with Visual Studio 2013. Now right off the bat, let's look at the Solution Explorer. If you notice, all of my files here have plus signs. That means these are new to the repository, but they haven't been committed yet. And that really shouldn't be much of a surprise to us right now. So let's flip back to our command line and do our first commit. So for this, I'll just say git commit, and then normally we want to put a message here. Now, if I just hit enter here, it will open up an editor so that I can type that in, but it's a lot easier just to do it as a parameter on the command line. So I'll say -m for message, and we'll just say that this is the initial project. And when we hit enter, we'll see that all of those files are committed. And now if I do get status, we'll see that there's nothing new to commit, so our first commit is actually complete. And if we look over in Visual Studio, we'll see that our plus icons have changed to lock icons. So this is showing that the files that we have on our machine are current with what we have committed in our repository. Now the project we have here is really simple. In fact, all we have is a button that's not hooked up to anything right now. And this is the same demo project that I use when I'm showing people how to use Lambda expressions. If you want some more information on that, you can check out my other video on anatomy of a Lambda expression. We're just going to use this project so that we can get a number of commits so that we can get comfortable using Git. So all I'm going to do is start out by just adding an event handler to our button. So we'll say clickMeButton.click plus equals, and then I'll hit tab twice to let Visual Studio go ahead and generate that event handler for us. And then inside our event handler, we'll just say messagebox.show hello world. Now notice in our Solution Explorer, our main window.xaml.cs file, the one we're currently working on, now has a checkmark icon next to it. That means we're currently in the process of editing this. So let's go ahead and build our application and run it, and then we'll see our functionality is just to pop up a hello world message box. Now to commit these changes, I'm going to go back to the command line, and we'll just say get status, and we'll see that we have our one file, main window.xaml.cs. So I could try to do a commit just like I did before. So I can say get commit -m added event handler. But we'll see that that actually doesn't work. That's because our file needs to be added before we can commit it, just like we did initially. Now, fortunately for us, Git is here to help us out. Look at the hint that it gives us. So it says use git add and or git commit -a. So the -a switch will let us add and commit files in a single step. So if I say git commit -a, and then we'll go ahead and add a message. So we'll say -m added event handler. This will add and commit the files at the same time. But something to note is that if I have two switches, I can actually combine them. So it's actually more common to see git commit -am that combines both the add and the message parameters. And so now if we hit enter, we do see that we have a successful commit. And if we look at Visual Studio, we'll see that our lock icon is back on the file that we just modified. So now let's go ahead and look at what our repository currently looks like. So we'll use git log for that. And this will show us the two commits that we've done, the one for the initial project and the one when we added the event handler. Now I want to point out the IDs for these commits. It looks like a GUID, a globally unique identifier, but it's actually a hash of the commit itself. And the primary reason for this is data integrity. All of the files, including all of the commits, exist on my machine. That means that if I know what I'm doing on the file system, I can go in and make a change to a previous commit. Now, if I do make those changes, the hash will no longer match, and so it will be rejected by the Git system. So this helps us give us confidence. Even though we're using a distributed source control system, we know that the contents have not been modified since they were initially committed. So let's start taking a look at some of the other features that we have in Visual Studio. So if I right-click on the file that I've modified and choose View History, this actually shows those same two commits, the initial project and where we added the event handler. And you'll notice we also have the first part of the hash. So we're showing the first 8 bytes of the hash for each of these commits. Now for a lot of the tools that we have in Git, if we do need to reference a particular commit, we can just use those first 8 bytes rather than typing in the entire hash. Okay, so let's make a few more changes and work a little bit more with Visual Studio. So for this, I'm going to take our event handler and I'm going to inline the code. And what this is going to do is create an anonymous delegate rather than the name delegate that we have here. So I'm just going to type in the delegate keyword and then paste the parameters and the method body from our separate event handler. Now this has the effect of inlining the code and creating what's known as an anonymous delegate, which is just a delegate without a name. And if we run our application, we'll see that we get exactly the same results that we had before. So now let's see how we can commit these changes from Visual Studio. For this, I'm going to use the Team Explorer. Now, if you don't have the Team Explorer already open, you can get it from the View menu. And these are the items that we have available to us at the Home tab for Team Explorer. Now, to get back to this, all we need to do is click on the Home icon. So wherever we are in Team Explorer, we can always get back to this location. So I'm going to click on the Changes tab, and we can see that we have one item, which is our main window.xaml.cs file. And as you expect, if we flip over to our command line and do a get status, we see exactly that same thing. Now, rather than doing the commit from the command line, we'll do it right here from the Changes tab in Visual Studio. So in this case, we'll say changed to anonymous delegate as our message, and then we'll just click the commit button. Now you'll notice we have a notification section here, and it gives us the first 8 bytes of our hash, and there's also a link to sync to share it with the changes on the server. Now we don't currently have a remote repository set up, so we don't have a server to sync with, but we'll be looking at how to use GitHub in just a little bit. Now if we go back to our command line and do a get status, we'll see we're completely up to date because we committed the changes through Visual Studio. And if we look at our log, we'll see all 3 commits: the initial project, where we added the event handler, and where we changed to the anonymous delegate. Now, the nice thing about understanding the command line and Visual Studio is that I can flip back and forth and use whichever means is easiest for me at the time. So for me personally, I found that there's some operations that I prefer to do on the command line, and there's some operations that I prefer to use through the Visual Studio interface. Now let's move on and look at branching a little bit. Now I'm going to say git branch, and this will list out all of the current branches that we have in our repository. Now right now we can see we have one branch called master, and this is the current branch. Now to create a new branch, we'll just say git branch, and we'll call this lambda expression. And now we see we have 2 branches, but master is still the active branch. Now if I want to change to the lambda expression branch, all I have to do is say git checkout, and then type in the name of my branch. And now we can see that lambda expression is our active branch. Now dealing with branches in Visual Studio is actually a little bit easier. If we go to our branches tab, we'll see that we have 2 branches listed, lambda expression and master. And notice lambda expression is the bold one. That tells us that this is the active branch. So let's go ahead and make some changes on this new branch. So I'm going to remove the delegate keyword, and I'm going to add the lambda operator, the equals greater than sign, in between the parameters and the method body. Now we have a lambda expression. And if we run the application again, we'll see we get exactly the same results that we had before. So let's go ahead and commit this change as well. Now I am committing a lot of changes. Normally I don't commit after every line of code, but I want to have several commits here so that we can look at them. So for this, we'll say changed to lambda expression, and we'll go ahead and commit that. And then lambda expressions have this cool thing called parameter type inference, which means if the compiler can figure out the parameter types, we don't have to type them in. Now, since the compiler can figure this out, these are still strongly typed. So we see E is still of type routed event args. We just don't have to type it in. And if we run our application now, we'll see we get exactly the same results that we had before. So let's go ahead and make a note that we added parameter type inference. Another common thing to do with lambda expressions is to use single character parameter names just because it is such a compact syntax. So we'll go ahead and just change sender to S. And again, if we run our application, we get the same results that we had before. And we'll go ahead and say changed to single letter parameter names. And we'll make one more change here. We actually don't need the curly braces if we only have one line in the body of our lambda expression. And we can also get rid of some of this white space. And if we run our application, again, we'll see we get exactly the same results that we had before. So for this last commit, we'll just say removed curly braces and white space. Now again, if you want some more information on the demo that I just showed, be sure to check out Anatomy of a Lambda Expression, which will go into some more details about Lambda specifically. But again, we're concentrating on what get gets us in Visual Studio. So I'm going to go back to the Solution Explorer. I'm going to right-click on the file we've been modifying and choose View History again. Now this time we see all of the commits that we've done so far. And in addition, we have markers for our branches, so we can see where our master branch is, and we can see where our Lambda expression branch is. And one really great thing that we can do from the history window is actually compare these changes. So I can control-click on multiple items, right-click and say Compare, and this will give us a side-by-side comparison that shows us what's been changed in these files. And we're not limited to just comparing branches here. I can go ahead and compare any of these commits that I like. And in fact, you can pick more than 2 files at a time if you'd like. Now, the really great thing about having all of this repository information on our local machine is that we can switch back and forth between branches really easily. So I'm going to go back to the Team Explorer, and we'll go to our branches. And if I want to go back to my master branch, all I have to do is double-click on it. And notice that my file in Visual Studio updated to go along with that branch change. Now, a really cool thing about Git is that whenever we switch branches, it actually updates the files in what's known as our working folder. So if I were to go into the Hello World and then take a look at the main window.xaml.cs, what we would see is this is showing what's currently showing in Visual Studio, which is the master branch that I have selected right now. Now, what that also means is that if we switch branches from the command line, it will be modifying the files in the background. So we'll say Git branch, and we'll see we're currently on the master branch, but let's go ahead and check out Lambda expression. Now we can see the Lambda expression branch is currently active, and if we look in Visual Studio, we'll see that it's updated as well to show that Lambda expression is the active branch. And then if we click back into our IDE, we'll get a pop-up that says the file's been modified outside of the editor because, again, that file's being replaced on the file system. So we'll go ahead and say yes, and we'll see the most recent file in our editor. So we can see we have the choice of changing branches on the command line, or we can easily change branches by just double-clicking between them in Visual Studio. So far, we've only been working with a local repository. That means all of these changes, all of these commits, all of these branches exist on my local machine and my local machine only. Now, I really like that because that means if I'm disconnected, maybe I'm on an airplane or a hotel in the middle of nowhere, I can continue to work on my projects and still maintain the history, the ability to roll back, and the ability to create and switch to new branches without having to have a connection to the central server. Now, unless you are working all by yourself, you probably do want a central server out there somewhere. And there's lots of options to choose from, including Visual Studio Online, which hosts Git repositories. Now, I'm going to show you some of the basics of using GitHub. This is one of the most popular repository hosts out there for Git repositories. So for this, I'm just going to open a browser and go to github.com. Now, one thing I really like about Git and GitHub is that they do hold your hand where you need it. So when you're brand new to the system, if you just follow the on-screen prompts, you're probably going to be okay. Now, I already have a GitHub login, so all I need to do is create a new repository. So for that, I'm just going to click on the new repository link. And for this, let's go ahead and give it the name of Video Git Sample 2013, since we're using Visual Studio 2013. Now, there are a few more options that we can do here. So we can put in a description, and then we can choose whether this is a public or private repository. Now, if you do want private repositories, you do have to pay for that, but public repositories are free to anyone who signs up. We also have the option to initialize the repository with a README, and that's a very common file. We'll look at it in just a bit, but I won't add it here. And then notice we have the option to add a gitignore file. So this is really useful. As you can see, there are quite a few different environments that we can choose from here, including Visual Studio, which is way down at the bottom. But since we already have an existing repository, we will not add that here. Now, if I was creating a repository from scratch and I started at GitHub, I'd probably add all of this and then bring it down to my local machine. But since I already have items on my local machine, we'll just kind of leave everything blank for now and then fill in the pieces as we go. Now, the last option we have here is that we can include a license along with this, and this has some of the standard licenses, including the Apache and the MIT licenses. But like I said, we'll just go ahead and choose Create Repository with a pretty much empty repository. So like I said, GitHub is really good at holding your hand when you're new to things. So notice that what we have here, we have a quick setup so that if we're using the Git desktop tool, we can set it up really easily. Or you can see how we can create a new repository on the command line. Or we can push an existing repository from the command line. Or we can import code from another repository. Now, since we already have a repository, let's go ahead and just use the command line here. And so what I'll do is I'll just go ahead and make this a little smaller so that I can see those commands. Now what I'm going to do is use git remote to add a reference to this remote repository. So when I say add, I'm going to create a mapping that I can use more easily on my machine. Now if you look at the instructions, we see we have git remote add origin, and then we have the web address for this particular location. So again, it's https github.com. Then my user ID, JeremyBytes, and then the name of my repository, video-get-sample-2013, and then .git. Now when I hit enter, all that's doing is creating the mapping. Now you might be curious about this origin. What we've just done is given an alias to this remote location. So whenever I say origin in my local Git repository, it's going to refer to this remote location on GitHub. Now using origin is just a convention. We can actually name this whatever we want. So let's push some files into our remote repository. So for this, we'll say git push, and I'll say origin master. So what this is saying is I want to push to the origin location from the master branch of my local repository. And when we hit enter, it will prompt me for my user ID, which is JeremyBytes, and it will prompt me for my password, which I will not say out loud. And then with that information, it will go ahead and push the master branch to our origin, our remote repository. So now I'm going to go back to GitHub and just refresh this page. So this is just the root of our remote repository. And now that we have some items up there, we'll see that our display's changed. Now there's a few things to note here. First, if we look at our branches, we'll see that only the master branch has been pushed. The Lambda expression branch has not. And we'll take a look at pushing that in just a bit. And we can also look at the commits that we have here. And in this case, it's just the 3 commits for the master branch, not the rest of the commits that we have on our Lambda expression branch. And we'll take a closer look at these in just a minute. So let's go back to Visual Studio and take a look at how things have changed there. So if we go and look at our branches now, what we'll see is we have published branches versus unpublished branches. Now the published branches tell us that they are on our remote repository, and the unpublished branches tell us that it's only on our local machine and it's not part of our remote repository. Now this is one of the screens that's changed pretty significantly in Visual Studio 2015, so it actually keeps the local branches and the remote branches a little bit better separated. So we've seen how to push a branch from the command line. We just used the get push origin master. How do I push a branch from Visual Studio? Well, it's pretty simple. We'll just right-click on the Lambda expression branch and say Publish Branch. And we'll see that we get a message that says it was successfully published. And if we go back to GitHub, notice that we have a message here that lists Lambda expression as a recently pushed branch. So even without refreshing the page, we actually get some updates based on our remote activity. And if we refresh the page, we'll see that now we are showing 2 branches. And let's take a look at those. So here we can see both our master branch and our Lambda expression branch. And it's really interesting when we look at the comparison. So notice this says the Lambda expression branch is 4 commits ahead of master. That means since we've branched off of master, we've actually made 4 commits to this particular branch. Now, before we look at merging anything back, let's just go back to our main screen. And here we're on the master branch, and we can see that right here on the screen. Now, one thing we see here is there is a suggestion to add a README file. And if you look at the repositories on GitHub, pretty much everybody has a README file. The nice thing about this is it shows up on the main page of your repository so that you can provide some documentation or additional information. So for this, I'll just say this is the sample project for Git Basics for Visual Studio developers. And we'll go ahead and add a URL where people can get some additional information. Now this is in a Markdown format, so if you're familiar with Markdown, you can style this however you like. Now I can actually commit this to the repository right here. That means I can actually make changes to file and code on the website. Now for code files, I would not recommend that, but if we're talking about making some text changes, sometimes it's really easy to just jump into the file and make that spelling correction. So for this, we'll just say added readme, and we'll go ahead and commit this. And by default, it will go ahead and commit that to the master branch. So now we're in a bit of a situation. We have a file that's on our server that's not on our local machine. So if we go back to our file system, we'll see that I don't have that readme.md file on my local machine. But it's actually really easy to get from the command line. Now to do this, rather than pushing from our machine to the server, we'll pull from the server. So we'll say get pull origin master. So we're actually pulling from the remote origin to our local master branch. And if we hit enter, we'll go ahead and see that those files come down. And if we go back to our file system, we'll see that now we have that readme.md file on our local machine. So now let's go back to GitHub and take a look at our branches. Now if we look at our changes, we'll see that our Lambda expression is still 4 commits ahead, but now it's 1 commit behind. And that's because we added that README file to the master branch, which is not on the Lambda expression branch. Now really what I'd like to do is merge the changes from my Lambda expression branch into the master branch. And for that, let's go back to Visual Studio. Now for this, I'm going to go ahead and click on the merge link, and we'll see that we have our choices of what branches we'd like to merge. So I'd like to merge from the Lambda expression branch to the master branch. Now this is one area where I appreciate the GUI tools that we have in Visual Studio. From the command line, we need to make sure that we're on the right current branch and then merge into the branch that we want. So it is a little tricky to get things in the right order. But from Visual Studio, we just choose our from and our to branches, and then we just click on merge. So now let's go back to our command line and just do a status. Now if we look at this, it says that the master branch on our local machine is actually ahead of the master branch on origin, our remote machine, by 5 commits. So this is telling us that we really need to do a push to get our local changes up to the server. But rather than doing that from the command line, again, we'll go to Visual Studio and look at these tools. So for this, I'm going to go to the Unsynced Commits tab of our Team Explorer. And notice that we have sections for incoming commits and outgoing commits. So this will show us things that are changed on the server that we don't have locally, and it will also show our local changes that need to be pushed to the server. So in this case, I'm just going to click on the push link, and that will go ahead and push those changes to the remote server. And if we go back to GitHub and refresh our page, now we see Lambda expression is now 2 commits behind master. And if we look at the actual commits, we'll understand why. So in addition to all of the changes that we had on the Lambda expression branch, on the master branch we added the README, which we saw before, but then the merge is also a commit. So that's why the Lambda expression branch is showing 2 commits behind master. Now we do have a lot of options here. One thing that's nice is we can click on any of these hash values and it will show us all of the files that were changed in this commit. So most of the commits that we had just had one file changed, like this one here where we added our event handler. But if we go to our initial project, what we'll see is all of our files have changed because we're adding new things. And so that includes all of the files from that initial project. So by doing this, we can actually look at what items are part of each commit. Now, one last thing I want to do before I go is I actually want to remove that Lambda expression branch. That was just a temporary branch, and I really don't want that published anymore. Well, in Visual Studio, I can right-click on the Lambda expression branch and choose Unpublish Branch. And then if we go back to GitHub and look at our branches, we see now it's gone. We only have the master branch. But this branch is still in our local repository, and we can pull files from it if we'd like to. Now, if we'd like to get rid of it entirely, we can just right-click on it and say delete, and now that branch is completely gone. So if we go back to our command line and look at our branches, now we see we only have the master branch left. So we've just barely scratched the surface with Git, but hopefully this gives you a good enough idea of how to get started and that it's not really hard to use. And based on our preferences, it's easy to use the command line, and it's easy to use the built-in tools that we have in Visual Studio. For more information and articles, be sure to visit www.JeremyBytes.com or follow the links in the video notes for some more specific information on how to get started with Git. There's a lot of really great tools out there, including Try Git, which lets you use Git interactively from inside your browser to learn the different commands. Well, that's all we've got for now, so go out and get her done.